Okay. Did everybody get their coffee?
Yeah, can get started, yes.
All right. Oops, sorry. Right. Okay, so to wrap up the math part, in particular the math part now, let's talk a bit about other formats. So what we've done so far was effectively source to web, which in many ways is easy because, first of all, you've got the source, which gives you the most information possible about your document. And you've got the most flexible, or currently most flexible available canvas to paint or draw your document on, which is the web. But what about other formats? What about other sources, which might be harder? Sources as in not necessarily the author source, as well as targets which are different than the web. Right, so the sources I want to briefly go to in this part of the lecture is something. First one is kind of called normally retrodigitized. What do they mean? Well, these are sources that come from originally printed material and that are then being digitized in some way in order to make them available as a file or somewhere and via the web. That second kind of is born digital, which means that those are documents which are actually generated from digital sources. However, the source is no longer available to us. And finally, the born accessible documents are effectively documents as we've seen them, where we have the sources, or at least the documents are created in a way that they contain everything that allows us to make them accessible. So the ones which are particularly difficult are, of course, the retrodigitized ones. So what are these in general? Generally, those are there's right. So yeah, right. So what are these in general? These are generally historical manuscript, as well as old runs of journals, old books, etc. And the way they are being sourced is usually in some sort of a fashion which some big organization like a library, a national library, an organization like, for instance, JSTOR, I'll show that to you what that is, or publishers retrodigitize it, scan things in bigger runs. Google Books was an example as well. Scan things in bigger runs and then make them available as some sort of electronic format, most of the time single images or PDFs containing single images of the digitized versions. And JSTOR, for instance, is a classic system where you have a lot of documents. So, for instance, let's have a look at mathematics documents, and they're all retrodigitized documents, and you can have access to them either directly via an account, or there's also access to some of these via. They've got a program for data for research where you can then work with these. Right. So here's. Search. Let's have a look. Let's have a look at one of these. Let's have a look. Let's browse by subject. That's easier. Mathematics. Let's talk to mathematics. Let's just pick one of those. American Journal of Mathematics. So you can see they've got journals from 1870 to 1920. And then you can look at some of these and for instance, okay, here's one, geometric aspect of abelian modular functions. Right, so here's the paper. And here's one of the versions. Here's the first page, and you can download it and you can get through some of these things. And obviously all this is a pure image. Even if you download it as a PDF, there is no content available for you to use. And the question now is, of course, what are we going to do if there's no content available for us to use? Well, there's various ways how to do these things. one common way is using an optical character recognition program on some of that content. That means we go from an image to some electronic representation, trying to find out what are the characters there, what are the words in a document, and then simply try to put together the original content of the document that we've just scanned. That is often very difficult, in particular for historical documents, and therefore there's various ways of not only automating that, but also to kind of try to proofread and add some correction to this, to the transcriptions. And for instance, there's projects like Zooniverse out there. I'm not sure whether some of you might be familiar with that, but Zooniverse is a way in order to crowdsource information from people primarily via identifying things in images, but also transcribing elements on pages and of old historical documents. So one of their flagship projects was, for instance, all the weather charting, the weather from 1914 to 1918 via various scan sources of weather reports for World War I during World War I. And they currently have old weather doing the same for World War II, where, for instance, people are tasked to correct transcriptions or transcribe directly weather reports of that nature here. For those of you who can't see the screen, so this is a weather report, which is effectively a huge table, but it has handwritten content in there for every hour of the day, what the weather is in a particular vicinity, i.e. in longitude and latitude, which has primarily been gathered by submarines, different weather ships, and so on and so forth. And as I said, it was very successful for World War I. For World War II, currently they are at 4%. Right, so it still will take a while until people have transcribed that properly and corrected some of their recognition. And they're using more than 2,000 volunteers. So what about math? Well, one of the problems is that while some of these systems work fairly well with regular text, so even when you buy a scanner, you normally get a piece of software with it which does basic OCR for you. It's particularly difficult for mathematical detection. And why is that the case? Well, because it's simply not just regular text. There's a couple of artifacts which make it difficult. First of all, it's more difficult to find where the math is in a scanned page. It's more difficult to analyze what the real layout of it is. So it's easy to, you can analyze quite quickly what are single lines. You can analyze quite well what is a paragraph, what is a header, but finding out where the math is, what the size of the math is, say, does it have a label? And then what is the actual composition of the mathematical elements is very, very difficult. It's very difficult. That has not only to do with because there's no dictionaries where you can look things up, which doesn't allow you to do some sort of a secondary or higher order recognition as you can do for normal text. So for normal text, you recognize all the characters, you recognize the distances between words, and you might be able to find sentences, and then you can have a higher order recognition running over that again and saying, okay, well, if we know, for instance, this particular piece of writing is in English, then I can start looking things on the dictionary and possibly cross-reference or cross-compare words, which might have errors in them, and thereby do some sort of error correction on particular characters which might have been misrecognized. In mathematics, that's practically impossible because there's no dictionaries. There's many different fonts, there's different scripts being used, and so on and so forth. All the usual problems that already make things hard for us to make things accessible is even worse when you talk about OCR. So what are the possibilities? Well, there's a bunch of generic OCR systems out there you can use, which generally do not do a good job. So the most commonly used one is, for instance, Abi Fine Reader. It's a proprietary system, and it has support for certain special fonts. So, for instance, for German Fraktur fonts, which are often used in math documents, or blackletter fonts, as well as Greek character sets, Cyrillic, and these things. However, when it comes to complex layout of mathematics, it's not particularly accurate. Other examples are, for instance, the Tesseract, which is now maintained by Google and was part of the Google Book project as well. Let me have a look at, I'll show you a couple of, oops. Right, here's an example of a paper. This is a page from a Canadian math journal from 1996, which is scanned. And I'll have that courtesy to Michael Dope, who's doing these things at the University of Manitoba. Now here's the math. It's not necessarily very demanding mathematics in terms of the actual notation. So it's got a couple of sums. It's got a couple of elements like direct sum elements and so on. Now let's have a look at what the example results are. For instance, from the Tesseract, that comes as a Word document. There you go. Let's have a look. Oh, those is the OCR result. Now for those of you who can see the screen, let's try to get that next to each other. So that's the result, and that's the actual paper. Right, so we can see the first line says central quotients and coverings. That's the header line, 467. That's the page number. Now that has been recognized very well. Now we get the next line, which is where. Fantastic. That has been recognized very well as well. Now we get in the math document, we get something saying F1 equals 1/2, or 1/2, the sum of 1 yada yada yada, and so on and so forth. And so we've got 3 sum elements, each have a 1/2 as a scalar in front of them. Now in the actual OCR result, we get as the third line in the result 1 1 1. Right, so these are all the 3 ones which come from the 1/2 elements here, because what the Tesseract thought is, oh well, this is a line clearly, right? Because it doesn't understand mathematical layout. And then we get F1 instead of F subscript 1, which is probably acceptable. Then we get an equals minus, and the minus here is obviously not a minus, but is the quotient line between 1/2, and so on and so forth. So you can see it's quite atrocious what you get as a result. Right? At least, and you don't get any of the special characters recognized, and so on and so forth. So though it's effectively unusable. I think I've used another system, which is GOCR, which is easily available. Let's have a quick look at those results. That doesn't even get the header right. That gets some of the numbers right. It's even worse. Right? So it's just. It really is just a mess of characters and nothing else. So what else can we do there? Well, there's one system out there which has been developed for more than 20 years and is actually specializing in math OCR, and that's called IIT, originally driven by Masakazu Suzuki from the University of Fukuoka, or Kyushu University in Fukuoka. But they're a fairly big group now, the IIT project. And let's have a look at what they do in terms of full text analysis. They have, since they're a proprietary system nowadays, we can only have a look at some of their results, which they give us on their webpage. I have a very old version of it, but it doesn't run on my Windows anymore. So, and unfortunately, IIT only runs on Windows. And let's have a look at where not downloads, some of the examples. So they had some here. Maybe I'm wrong. Sample files, there they are, sample files. So sample 1 page, Okay, so for instance, here's a page of differential equation with some math in it. And let's have a look how that comes out with their. Oops. Let's see how that comes out with their sample, with their system. So they can produce all kinds of different output formats. So for instance, the TEC and IML, which is the internal markup language. And the one we're looking at now is an XHTML page. And that XHTML page looks actually quite good. So most of the text is there. The math is there. The problem why math doesn't really display is because it's XHTML in an HTML browser. And it's if we have a look at those elements, those are actually MathML elements. So if you were to inject math checks into the page, it should actually all look quite nice. So obviously those are the demo documents they have on the website. In reality, it's probably not quite as fantastic. Some of these results. Right, so that's one type of OCR system, and those are effectively working on full page OCR systems. Other things you can have are what I would refer to as snapshotting. What is snapshotting? The idea there is that you kind of make an isolated observation of a particular element, which you know is mathematics, then crop that formula and try to do OCR on that. And there's a number of systems out there that do that. One, for instance, is MathBig Snip, which I believe I have running on my system here, right? So you can, right? Let's just have a quick look at one of the math elements that we had earlier. So let's have a look at one of these here. So what you do is you just say get LaTeX, for instance, and then you crop a particular piece of your screen. And then what do we do? Oops. And then we do OCR on it. Here you go. For those of you who can see the screen now, there's another screen that popped up, and it did OCR on it, and it gives me the LaTeX formula with it, and it gives me a translation of the LaTeX formula from the original, and that's actually pretty good, right? So you can see now that it recognized the entire formula that you took from the page we've downloaded from the IIT site. Now this is a really nice page in a way, because it's a well-designed PDF document, which has clearly been compiled from LaTeX. Let's have a look at an older document. We've opened up a document earlier from JSTOR, and that's, for instance, this one here. Let's try the same thing with this. Take a snapshot of that, say, for this particular formula, and see what happens. And what do we get in terms of OCR and the LaTeX? So the formula is open parenthesis beta z close parenthesis pq to the 5th pt, and that's all pretty much there. The only thing that's probably not entirely right is that the row here is there's a row times the open parenthesis z theta. No, that's chi. It is recognized as a superscript dot, but otherwise everything else seems to be quite all right. Right, so that's one way of doing these things. Another way of doing these things is using a system called Equatio. I've got a link here. And the nice thing about Equatio is that you can install it inside your browser environment, meaning that you can now simply, here's a piece of math, run Equatio from here, and it opens up a toolbar at the very bottom of your screen, and now we can snip out one of these things and just which one are we going to take? Let's start with an easy one. Let's start with this one, for instance. An equation.
N raised to the -7/8 power is less than German RZ.
So you could here now, for those of you who can't see what we've recognized on the side, you could now see what we've recognized on the side in terms of, or you could listen to it, what we've recognized on the side. Let's try a different document. Let's try one of the empty ones, for instance. Again, same trickery here. Let's do this.
The absolute value of f of x is less than or equal to c times the absolute value of x.
Right, so and it reads it out nicely as well. And so again, that was all being done with OCR, and let's now, for the final attempt, let's try one of these old papers from 1929. Again, let's get Equatia going, wherever it was. Where is it? Oh, oops, that's not what I wanted. Sorry. I'm not quite sure what happened to my example now. Oh, here it is. Sorry. Yeah, let's for the sake of brevity, let's take this one where that comes out well.
Beta z times open paren bt close paren to the b power equals 0.
Right, so that recognized it quite well, with the one exception that, as you can see, this is probably, and it's difficult to see here, is probably a 6 here, not a B. But in general, it recognized things quite well. Again, why is it easier to do in isolation? Because you know it's mathematics and you can kind of concentrate on the layout exclusively. You don't have to worry too much about the surrounding text. Can do a bit of surrounding text as well, I suppose. I don't know. Let's try the whole thing with.
Determined by t equals v sub 2 comma times comma t sub 6.
Right. So now you notice that it has misrecognized the low dots, the dot, the ellipses here as times. And if you're wondering what the speech in the background is, of course, well, that's the speech rules engine system, which is used to generate the speech.
Something which is multiple lines. Can we try that?
Yes. I had a nice example there yesterday. Last night when I played with it. Let's try multiple lines. Where are multiple lines? Hold on, I'm sure I think I've got an example somewhere, which is. Yes, let's try this one here. Let's try that one. Here's one with multiple lines. Oh, but then since this is a TIFF, we probably get we probably can't do that. Anyway, let's try multiple lines with math snippets first and see what we get in terms of output. Here's a nice multiple line one, right? Let's get the math snippets going. Let's get the whole thing. And if you look at the LaTeX that comes back, this is nearly perfect, right?
Very good.
This is a very, very impressive tool. Now, let me have a look whether we can we open that in the browser. The problem with
multiple lines, it will only consider the first line, I guess, when it comes to getting LaTeX using math.
Oh, does it?
I guess, yeah. I tried doing that once, and it considers only first line, and then it gives.
If I could find that again, let's try that again. I thought it was.
Try to paste it in some editor, copy and paste and see.
There it is. So it seems to be. It looks all right. Does it not?
Oh, Poonam, that
Okay.
was with older version.
I don't know. It's
This
very
is the-
difficult to see. I understand, but here that doesn't that look right?
That was the issue with older version, Poonam. This is the newer version
Okay.
of matrix snipping tool.
Right. So
Okay.
this math I've upgraded last night. So yes. So that seems to contain all 3 lines.
Yeah.
So there, I mean, obviously this is a proprietary system with where you have, I think, per month 53 formulas you can use. So they're probably, you know, who knows, after those 50 run out, maybe they'll just reduce it to the first line. I don't know. I mean, there might be all kinds of trickery behind it.
Yes, that happens, Volker.
Yeah.
Giving you output.
Yeah,
I have tried that.
people want you to buy their systems after all. Let's try it, but just while we're at it, and while it's always good fun to play with these things. Sorry, I mean, if you, this is okay. Let's convert this thingy here to PNG. But I want something to go in the browser. Right, now we have this in the browser. Let's see whether we can do anything with Equation on that one. And of course, it's not an HTML page, so it doesn't like that. Yeah, sorry. So I can't really do that now. Sorry. Would have been nice to play with it. Anyway, I try to put an example together at some point. For this, maybe okay. Let me one final attempt. Maybe we'll find a nice long equation on one of these papers. No. Okay, let's not waste time with this.
Both these tools are proprietary. Equatia is also proprietary.
Yes, Equatio is being done by a company called TextHelp in Antrim, Northern Ireland, and it has a free version which anybody can install, and then what you can do, and then it has a premium version which allows you to do also speech recognition and these things as speech input. I want to show that next week at some point, the speech input and some of these elements. I didn't get that to work yesterday. They promised me to give me some tech support as soon as they can. Yeah, as soon as I have time. And the nice thing about Equatio is, and that's particularly nice, is that you can use it straight away in system like if you just use say here's a Google document, right? Let's just use, where is Equatio? Let's do Equatio, and you can now start just putting math from here to there, and have it read out and whatnot. And then you can insert it, right? So right now I've just inserted the typed math. Where is it? It is not there. Obviously, as soon as I demonstrate it, it doesn't work. But you can effectively, now the math isn't there. It takes a while. But effectively, you can take the math you've just scanned from somewhere else and recognize and have it copied into your own document and all that. And as I said, there's also speech input, which currently doesn't work in my setup, but I'll try to demo that at some point next week, because there was a question on that. I thought Poonam was the thing, or was it Akila, or somebody had a question on that the other day. How about speech input for mathematics? So we can play with that hopefully next week.
Akila had it.
Yes. Right, so let me finish off for today, because I'm mindful that we only have about 10 minutes left, and I'm also mindful that I have another 10 slides to go through. Well, we don't have to do that. We can go through some of them only. Right, so that's what I wanted to say about kind of retro digitized documents, there are still a lot out there, and there's a lot of nice little tools you can play with. Some are really useful, some are, and as you've seen, the general OCR tools are generally not useful. Now, what other documents do we have we want to talk about? Well, born digital. What does born digital mean? Born digital means effectively that you have a digital document which has been compiled from some source, right? But the sources are not available anymore, or at least they're not available to you, and not available to you at that right moment where you need to find out something about the document, i.e., for instance, make it accessible. General use cases, you have a PDF document which has been compiled from something like LaTeX, Word, or something else, and now you want to make it accessible. Unfortunately, you don't get to the actual source, and therefore you can't just convert it. You need to somehow get to things inside the PDF document. Obviously, that doesn't only apply for PDF documents, but there's other document formats like rich text format, which was a proprietary format by Microsoft. They don't really support it anymore because they've also now moved towards PDF. And PostScript is the precursor of PDF, of course, which was primarily geared at printers only. But all these can be converted pretty much losslessly to PDF. I mean, all the content they contain can be converted to PDF. So what if PDF is our only source? Well, there's a couple of ways how to make it accessible. The easiest one is, for instance, that Acrobat Reader already offers you ways of just reading it out directly. And it also often works with multiple screen readers straight out of the box. There are ways of translating things inside browsers. For instance, Chromebox used to have a module integrated, which simply would transform the PDF into some sort of a web document. Now, the problem is, of course, as usual, most of these tools only work for pure text. Where they don't necessarily work are for, for more complex texts, where you have problems with the reading order, for instance, if you have multiple column elements and if you have column spanning elements, that often breaks these tools up. If you don't have alt text for images, of course, where should it come from? That will also be ignored. Headers and footers can interfere, and all these things can be quite difficult. And the problem is, as soon as you have any more complex content, i.e. math, of course, as well as other things, then you can't really work with these PDF documents and these standard PDF readers alone. And that is a commonly known problem. And the problem is, and unfortunately, it's a very little understood problem by most people who work with PDFs. And the problem is, why can't we just get to the math, for instance, in a PDF document? Because in many ways, it's not there. And why is it not there? Well, because the way PDF documents are structured, for those of you who don't know how they're being structured, is they're being structured in terms of arranging things along a baseline. And you just have effectively a baseline on which you arrange characters, and these characters are arranged with a particular base point, and you don't have really the information of what that character is necessarily, or how that character is actually being drawn on the canvas, or in that case on the printed output or on the screen. And I'll show you an example where that comes up in particular. So this is our original example. This is the Rademacher paper, and this is that the PDF? Yes. And let me get that. Let me download that PDF. And well, that's not just. Let me copy this out here, right? And let's copy that to copy that into an Emacs, for instance, just to show you what we get. So I've just highlighted the entire a big equation, and oops, now I've lost my Emacs. Where did it go? That's the one. And what I get here is the equation is the product of j from 1 to n, 1 over 1 minus x to the j equals, and so on and so forth. What I get actually is a comma yn, j equals 1, 1, 1 minus x, j equals x, and so on and so forth. So the main problem why I can't get anything out there is because these elements are not necessarily represented in the page as they are being printed. And secondly, they are in various fonts which are being mapped to internally to something which is not necessarily the element that they represent. So if I copy out just a single word, what I get is I get exactly that word. If I copy out the single product element, what I get is a Unicode point in some font which has to be looked up somewhere somewhere else in the document. And so as such, it is not straightforward to get to these things. Another problem is, and that's is that some of these the outline and how the characters are being put in relation to each other do not correspond to the mathematical relations that they actually mean. So effectively, the j equals 1 to n are not necessarily in the same line as the rest of the elements, and therefore it is a considerable and difficult problem to solve. And there's been work on that, of course. I have done some of the work with some students and my group in Birmingham in already 2008, where we did something called the Maxtract system. I have a couple of examples of the results from that. The idea there was that we kind of tried to reconstruct what is in the PDF document with a grammatical approach. We're currently using the best bits of that again in the project we have at IIT. In the Ravi project, but we're now, instead of what we did in the Maxtract system, was we had a little homegrown parser for PDF, which didn't go very far and wasn't particularly good, and therefore the whole kind of, we could potentially do at least 5% of all potential PDF documents. Now we're doing all this in a comprehensive approach with a client-side rendering, which should hopefully give better results in terms of the extraction. And I'll just show you two examples. One is a single column document here. There's the original PDF, and there's a lot of math in there, of course. Big integral equations. And the result Maxtract would produce for this one is actually not that bad. The lines, so it tried to do the entire page, meaning that it had a hard time sometimes recomposing the lines and always tried to center these things. But in general, the math was quite well recognized because in many ways there was no real recognition involved. All it did was extract it correctly and then try to reproduce the layout using a grammar. I'll show you a less good example, of course, because we were certainly not perfect. So this is a 2-column paper which has particular nasty bits in there, difficult fonts. It's logics, meaning that there's a bunch of quite unusual characters as well as layout of characters. And the result for that, as you can expect, does not look quite as good as the previous one. First of all, the two columns don't always come across well, and some of these inline math elements are simply misinterpreted. So you have things which are being interpreted as math elements which aren't, and vice versa. Right. So Other approaches and solutions to this problem, the Infi system as a solution, they've had originally just an OCR solution. Lately, they've re-implemented some of the ideas we had in Maxtract. In particular, they're using some of Akio Fujiyoshi's work and his lab. They have very nice tools in order to work around the bounding box problems of characters in PDF documents and have quick extractor libraries there. And I've put that just to show you there's an entire I've got an entire collection of these tools, and they're quite nice to play with. And if you want to do your own stuff with it, they're certainly something to work with and easy to use. I'm mindful of the time. That's why I'm not harping on about Born Accessible now, because this is where we can start tomorrow easily, and then we'll start looking at some of these examples in particular pertaining to graphics and diagrams, because they occur in these documents and the examples I've put together there as well. Right, so let me summarize briefly. What we've done today was effectively finish off the math conversion. We've looked at some of the outstanding issues and put together some ideas of what authors as well as people doing conversions have to heed or what advice they have to follow in order to do a good job and make things accessible easily. And then we looked at some of the other formats in which documents can occur, particular things in image format and retro-digitized documents, as well as some of the PDF problems we've looked at. And that's where we're going to continue tomorrow. Thank you. All right, any questions while you're still here before you enjoy your Friday evening?
There is a tool to add equations in Microsoft Word, right? Can we use that? Is it accessible? Does it make the math accessible?
Which tool is that? Sorry, I didn't get the beginning of the question.
She's asking about equation editor in Microsoft. Word, we have a equation editor as a add-on which we'll be able to use for typing out equations. Is that Aguila?
Yeah, the inbuilt formulas and equations.
So when you say make accessible, I mean, do you mean get the make the Word document that has been created with this accessible?
Yeah, does the screen?
What do you mean the input being having in? Well, yes, no. If you type your Word document in, use the equation editor, and then use Pandoc, for instance, to put it on the web, you get the equation out correctly. Yes. So I think in some of our examples that we had a couple of lectures ago, one of them was a Word document, and that worked. So there's also, I might be wrong there, but I remember seeing that you can now use just LaTeX syntax, just typing it in the Word equation editor. So you don't have to go through any of these hoops and tricks with what is it, math type or any of that.
Yes, Walker, that is correct.
Yeah. And math type is again a bit costly also. Subscription, yearly subscription, and it's very costly too. Yeah.
So is there, whether you're taking a snippet or whether you put a bounding on an equation and you do conversion, is there any work which actually goes back and compares with the original and tries to fix it?
Tries to fix in what
at least
sense?
Identify the problems. Like, let us say, what I'm saying is you're going through a process of getting, let's say, a LaTeX out, okay, and then you, which could even be originally whatever it was generated. So it is an image, and you get the image back, and then compare this image that you had created through the process of your conversion, and then see any discrepancy and.
Well, there is some work in terms of in terms of research in order to do some of these recognition problems, right? I'm not sure in what way, whether they are used in any of the more product-ready or commercial systems like Equatio or MathSnippets. So there's libraries out there. What is it? Is it called Backdrop Library? Or I have to look that up. There's a particular JavaScript library, for instance, where you can overlay images and you can see whether the rendering of something has changed.
Okay.
So you can use these things. So there's for instance, there's the one where you check for rendering engines, whether the rendering of certain fonts or of pages have changed and so on. And I know a colleague at the AMS, for instance, who's using that quite heavily in order to work out whether anything has changed in terms of the rendering of their online channels, the American Math Society online channels. I have to check again what the name of the library is.
Yeah, so the idea was that can we have an iterative system rather than just a one side feed forward flow? Like, you know, so can we somehow iterate over it?
Yes. Yes, I have a colleague I used to work with, Alan Sexton. He tried some of these experiments. Yeah, we're kind of iterative and kind of have an overlay where you then realize, hold on, this particular element where you say we had that example where the B was recognized instead of the 6. If you put the overlay over there, then you should probably see a discrepancy, right? The problem is just always, and that is primarily with old and historical documents, is that if the resolution of the actual scanned image is not particularly good, not particularly high, then this is a very, this is a very fragile process, because then it kind of, you get it. It depends very much how good your cleanup of the original image then was, and so I remember Alan experimenting with it, and he didn't have particularly good success.
And also the old fonts may not be available. That may also be a challenge.
Yeah, that is another problem. So that's a common phenomenon when you play around with these snippet tools, particularly on old documents that contain black letter fonts, i.e. the old German fonts, because those fonts have really changed over time. And then you notice how much better they become once you get into the 90s. So old journals from the 90s and so on, where LaTeX fonts have started being used throughout the board. And all of a sudden, the results become a lot better.
Okay. Any other questions?
So Equatio, the snapshotting tools, right? Is there any use case for a person with visual impairment? They can't see where they are snapshotting, right? So what is the use case of those tools?
This for document.
Right. So what is the Equatio? The main point of Equatio is support for dyslexia. So the idea for the snapshotting tool there is that if you have a hard time kind of understanding what all these symbols mean in front of you, because you're dyslexic and they kind of change positions if you like, then you use the snapshotting tool and it reads it out for you.
Yeah,
so in terms
also,
of visual impairment, it's not quite that good.
Actually, what we are seeing is in all these textbooks that we are seeing from NCERT and all, many times they just put image for the equations. So if somebody is doing creating an accessible document, so it's not like a person who is visually impaired, but let's say you are an organization which you want to create an accessible document, these tools will be very useful because you can actually then get into a format which is accessible.
So for that, INT is not better. This is which is better.
INT.
You mean in terms of well, it's different use cases if you like. So INFT is particularly good if you have if you want entire documents, if you have scanned journals, for instance, etc. Because obviously, if you have thousands of equations in your papers, you don't want to go about and snip every one singularity. And whereas these other tools are primarily aimed at single element extraction. So here's an equation I want. I snip it out. I'll put it in my own paper. That's plagiarism. Or here's something I don't understand. I grab it and I let it being read out. And as I said, and just the tools that Text Help is building are primarily aimed at dyslexia support. So they do yes, it is helpful for some people with visual impairments as well, but not necessarily. Definitely not for people with blindness because they don't have the access.
Volker, isn't Equatio using MathPix at the backend?
It's using what in the backend?
MathPix.
It could be. Because in terms of quality, I think they're pretty much the same.
Yeah, I remember reading somewhere like they're using actually MathPix only at the backend.
Yeah, it could be. I know they have somewhere a list of things they work of. I think they have a list of other systems they're using in Equatio. I know they're using JSMol, for instance.